Hello everyone, welcome to a search and rescue mission by team number 14, codename High Voltage. This is the obstacle bot by me, Sean Weaver. Studies show that nearly 15% of combat-related deaths are potentially survivable. As a statistical figure, this is a pretty staggering number. My team proposes a swarm of 4 robots, including a locator bot to search for survivors, an obstacle eliminating bot to clear the path to and from the survivor. I'll be covering this. A supply bot for medical procedures, and a transport bot to get the survivor out. Here's the look for the final design. We have the platform arm with the 2 hinges controlled by the servo motors, the shoulder and the elbow, the 2 distance sensors, the eyes as we call them, the 2 independent DC motor drive tracks, 1 on each side, and then we have the platform here that extends out the back using a DC motor and these tilt servos, and then we have the onboard tilt sensor. So here's an example of the ramp extending out the back. That arm can actually be used as a platform to go over objects that are too heavy so that other members of the swarm can actually drive up and over the bot. Here's the circuit layout for that design. We have the 4 servo motors for the arm platform, the front elbow and the shoulder hinges, the 2 parallel distance sensors for depth perception, the tilt sensor that's on board, I'll show that later, the 2 independent DC drive track motors for navigation, the rear ramp extending motor, also a DC motor, and then 2 tilt servo motors to lower that ramp. Here we have the flowchart for the obstacle bot. We'll start here, scan continuously for input from the hub. We get that serial input, it'll call us using the obstacle keyword, not object. We'll read the input, actually get the location data in the form of coordinates from it, and go to that point. Once we get there, the bot will attempt to center up on the obstacle, scanning if it's further left or further right from the obstacle. Once it's centered, it'll lower the arm to a scoop position and drive a distance and up under the obstacle. It'll attempt to pick it up, and if the sensor was not triggered, the tilt sensor, the lift was successful, and it will simply back up while carrying the object, turn the direction, drive a distance, put it down, basically just set it somewhere else and print that it was removed. If the tilt sensor was triggered, the lift was unsuccessful, it'll lower the arm back down, back up a bit, raise the arm, and then basically place it in a ramp until the tilt sensor is triggered. It'll stabilize the arm and extend the rear ramp, saying that the obstacle is bypassed. So here's the code for that design. It ended up being pretty long. It was almost 500 lines. Here's just a little snippet of the loop function over here. So it was absolutely crucial for a lot of the basic functions to be combined with the more complex functions. Some, like the drive to function, did several computations and actually made it really easy to basically just get the bot from its starting position all the way to the obstacle just in one command. And here's the demonstration. This would be option number 1. An object is light enough to pick up. In this case, it's a rock at coordinates 2, we'll just say. So you can see the servo motors of the arm slow into a comfortable carry position, and it will repeat the coordinates that we're heading to. You'll see this by engaging the DC motors controlling the drivetrain. And once we get to that obstacle, we will offset the distance sensors so we can show that centering function. And once it rolls up in the object, it will attempt to center on it, in this case turning right. So give it what it wants and center the object. So it'll lower the arm into the scoop position, and it wants to drive in closer, so we'll give that the distance it's looking for, and it will now attempt to lift the object, as you can see by the servo motors here. And the lift was successful, so we are now moving the obstacle. This is simply done by lifting, pulling the object out, and depositing it somewhere else. Now it's setting down the obstacle, and once it's all said and done, it'll simply just say the rock has been cleared. So all in all, hostile events are never going away, and so we're going to need to optimize search and rescue missions. We made this proposal because robots can limit risks to other personnel and potentially save lives. And here's really the one main reference from this part of the project, just the statistic feature at the very beginning.